Hello and welcome to the walking talking topic on circle theorems, question number 5 with me, Mr. Barton. Now I'll warn you now, this is a bit of a tricky question, but it's definitely doable. So let's take a look at it. Diagram shows the circle with centre 0, standard. PT is a tangent that touches a circle at C. Right, first bit, the reflex angle at the centre of the circle is 280. Now that's a little blast from the past. Reflex angles are angles between 180 and 360 degrees. So I'm looking for the big fat angle, so I think it's that one all the way around there. That's got to be 280 degrees. And find the size of each of the following angles, and you've got to give a reason each time. So B to A to C, that one there. Now just be careful, before you start thinking, well, it's angle at the centre. It is, but we've not got the right angle at the centre yet. It goes B to A to C, so it's got to go the same, B to O to C. So it's that angle there. So if that's 280 degrees on one side, and angles around a point add up to 360, I think that's got to be 80 degrees there. So B to A to C has got to be half the size of that using the angle at the centre theorem. So I think that's going to be 40 degrees. We'll just mark it on as 40. My reason, angles at the centre are double angle at circumference. Done. Now, what about this one here? BCP, B to C to P. Now, for a start, it's not even on there. So out comes the green ruler, just to mark it on. B to C to P. E-bomb's down there. Now, how big's that angle? So it's B to C to P. It's this big angle here. Now, the key to this is to realise that that angle is split up into two angles. That angle and that angle. And the first part of that angle is 90 degrees because it's a tangent meeting a radius. So we have here, I'm going to put a 90 degrees there, and I'm going to explain it. Tangent meets radius at 90 degrees. So that's that bit. But what about this little bit of the angle? The B to C to O bit. Well, again, you've got to switch on here and think, I've got a triangle. I know the top angle, 80, but I also know that these two sides are equal because they're both radiuses to the circle. So in fact, what I've got is an isosceles triangle. So if that's 80 degrees, these two angles must be exactly the same. So I reckon that's 50, and that's 50 to give me my 180 I need. So my angle BCP is made up of my 90 degrees and my 50 degrees. I'll just justify that. Isosceles triangle. Give that a little jot down there, isosceles triangle. So my total size of my angle must be 140 degrees. That's a flipping tough one, that, but an enjoyable question nonetheless.